The year is 2025. The sky is no longer just a highway for airliners, it's a battlefield. In this new era, the most powerful weapon is often the one you can't see or hear. Welcome to the world of stealth technology, the art of moving undetected, striking before the enemy even knows you're there. For decades, this has been the cornerstone of American military power. Stealth allows the US to project force anywhere, giving commanders options that would otherwise be impossible. Imagine needing to disable enemy air defenses before a major operation. A conventional air force would face a wall of missiles and guns, losses would be high, but a stealth aircraft can slip through, dismantling defenses piece by piece, like a ghost. This is not science fiction, it's the reality of modern warfare, shaped by those who master invisibility. The US has invested trillions to build this edge. The F-22, F-35, and B-2 are more than planes. They're symbols of technological supremacy. This invisible fleet ensures America can control the skies, operating with a freedom no other nation can match. For over 30 years, this technological gap has shaped global security. But technology never stands still. What's revolutionary today is standard tomorrow, obsolete the day after. The advantage of one power is always a challenge for another to overcome. China and Russia have spent years searching for a way to counter American stealth, looking for a crack in the armor. Now, with new developments in space, China may have found a way. The game is changing. The sky is about to become much more transparent and dangerous for everyone. The era of invisible dominance is under threat. The question is, who will adapt first? The next chapter in air warfare is about to begin. The stakes have never been higher. The cloak of modern warfare is slipping. What does it mean for an aircraft to be stealthy? It's not true invisibility, but making detection by enemy sensors, especially radar, extremely difficult. Stealth is about minimizing a machine's signature, like a whisper drowned out in a noisy room. The goal: make a jet look like a tiny spark on radar, or nothing at all. This is achieved through clever engineering and advanced materials. The shape is crucial. Flat surfaces and sharp angles deflect radar waves away from the source. Special radar-absorbent coatings soak up energy, converting it to heat instead of reflecting it. Together, these features make stealth jets exceptionally hard to find. But stealth isn't just about radar. Designers also reduce heat from engines and electronic emissions, masking the aircraft from infrared sensors and enemy eavesdropping. The ultimate goal: a low observable platform, quiet across the electromagnetic spectrum. This holistic approach is what gives American stealth aircraft their legendary ability to operate undetected. It's a constant battle to stay ahead of detection technology. Stealth is not a single trick. It's a system of systems, and for decades it's worked. But the rules are changing. Radar is the electronic eye of the sky, using radio waves to spot objects at a distance. It works like shouting in a canyon and listening for the echo. A pulse is sent out, and the reflection reveals what's there. Most air defense radars are monostatic, transmitter and receiver in the same place, scanning for echoes. Conventional aircraft reflect radar waves strongly, making them easy to spot. Stealth jets, however, scatter and absorb radar energy, sending only a faint echo back. To the radar operator, a stealth jet might look like a bird, weather, or nothing at all. This is the Achilles heel of ground-based air defense. If you can't see the target, you can't shoot it. That's why the US has been so confident in its stealth advantage. Stealth aircraft could fly into defended airspace, complete missions, and leave undetected. For years, there seemed to be no answer to this problem. The hunter was blind, but new technology is changing the game. The question now: can stealth survive in a world where radar is evolving? The answer may come from space. China didn't just try to build better ground radar, it looked to space. Enter the dual radar satellite system, a form of bistatic radar that changes the rules. One satellite transmits a radar pulse. A second, in a different orbit, listens for echoes. This separation creates a new geometry for detection, one stealth jets weren't designed to defeat. Stealth shapes deflect radar away from the source, but now, away could mean straight to the listening satellite. The very design that hides a jet from ground radar can reveal it to a satellite above. In 2023, China demonstrated this concept using 2 commercial satellites, successfully detecting an aircraft in flight. It's not yet a full military system, but the physics work. China has shown it can use satellites to create a space-based radar fence. This fence could see what ground radars have missed for decades. The implications are profound. The invisible is becoming visible. The stealth game has a new player. China's dual satellites exploit simple geometry to spot stealth jets. A stealth jet deflects radar in unexpected directions. Ground radar misses it, but a satellite in the right place can catch the reflection. This creates a giant, invisible tripwire in the sky. Even the best stealth aircraft can't make radar energy vanish. It can only redirect it. Multiple satellites can triangulate the position, speed, and direction of a ghost aircraft. This method is especially effective with low-frequency radar waves, which stealth jets struggle to defeat. Space-based bistatic radar can serve as an early warning system over vast areas. The cloak of invisibility starts to fray. US stealth bombers flying covert missions may now be tracked from orbit. Detection doesn't guarantee a kill, but it's the first step in breaking stealth. Once you know a ghost is there, you can hunt it. The era of perfect invisibility is ending. This technology could shift the military balance between the US and China. For decades, American war plans relied on stealth to offset China's numerical advantages. If stealth jets can be seen, they can be targeted and destroyed. China's new capability erodes a core pillar of US air power. If both sides can track each other's stealth assets, the advantage is neutralized. Warfare could revert to numbers, pilot skill, and missile tech, a scenario that may not favor the US. China's industrial base could overwhelm a smaller, high-tech US force. The ability to detect stealth from space means no sanctuary for US forces near the conflict zone. Air bases and carriers could be under constant watch. The world shrinks for the US military and expands for China. The playing field is leveling. American strategy must adapt or risk losing its edge. China's dual satellite system is promising, but faces big hurdles. Covering the vast Pacific would require hundreds, even thousands of satellites, an enormous financial and logistical challenge. Satellites are vulnerable, easy targets for anti-satellite weapons or jamming. In a conflict, the US could blind the system by taking out key satellites. Processing the massive data stream is another challenge. Distinguishing a stealth bomber from birds or drones is no easy task. Sophisticated AI and real-time analysis are required. Even if detected, low-frequency radar may only give a rough location, not enough for a missile lock. China would need to cue other sensors for a precise track, creating a complex kill chain. Every step is a potential failure point. The US could exploit these weaknesses. Turning detection into destruction is not guaranteed. The race is far from over. The US won't stand still in the face of this threat. First, electronic warfare, jamming Chinese satellites with noise to drown out stealth echoes. Second, hunting the hunters. US Space Force could target Chinese radar satellites, creating gaps in coverage. This is risky, but the threat alone could deter China's reliance on the system. Third, innovation, new stealth designs and materials to defeat a wider range of radar frequencies. Future jets may use active cancellation, sensing radar and generating signals to cancel the echo. The US may also shift to swarms of smaller, cheaper drones, confusing enemy sensors and increasing survivability. Some drones could act as decoys, others as jammers or sensors. The goal makes targeting so difficult that even if detected, stealth aircraft can't be engaged effectively. The contest between hider and seeker continues. Adaptation is key. The race is on. China's dual radar satellites don't end stealth, but they end uncontested dominance. The age of invisible impunity is closing. The sky is becoming transparent. Invisibility is now a fleeting condition, constantly challenged by new technology. Every breakthrough is met by a counter. Stealth versus counter-stealth is an endless cycle. The US developed stealth to defeat Soviet radar. Now China uses space-based radar to defeat US stealth. The US will respond with new innovations. Relying on a single magic bullet is over. The future belongs to those who integrate manned and unmanned systems, space and cyber, electronic warfare, and advanced networking. The ability to sense, decide, and act faster than the opponent will matter more than any one aircraft. Survivability will come from agility and adaptability. As of now, the balance hasn't tipped, but the warning shot has been fired. The invisible battlefield is becoming visible. The race, for the high ground in tomorrow's conflicts, has begun.